in the section 10.4, it is a very short section that have kind of two formulas for area and the arc length when we are in the polar coordinate system. Now we of course did this area and arc length formulas like when it is in the direct Cartesian plane, but here we are going to do a similar calculation when the things are given in the polar coordinate format. So if the coordinates are expressed in the polar system, this is the equation that you have to use for the area, and this is for the arc length. Right now you have to kind of remember both these formulas, and let's do some examples. The first question is asked to find the area enclosed by one loop of the four-leaved rose. Remember, we spent a significant number of time to draw the graph of four-leaved rose, right? Remember, for that we started from here and we went like this and then come down and up, and we have a curve like this and like this, and then go up and then down, and we end up like this, right? And anyway, this should be a symmetric curve. Okay, now although it is easy to draw these four leaves like this, you should understand that if you are plotting the curve from the scratch, it will not follow the same order. Okay, it starts at here and go to the pole, and then it will complete this portion, and then like this, right? And then it will go up, and finally it will complete the loop at here, right? That's how you can, like, that's how the points are created when theta is increased. We did this example extensively in a previous video, right? Okay, so anyway, we have this one and we are asked to find the area enclosed by one loop, so we just have to find the area in one of these loops, right? And if you follow the pattern of drawing these curves, you can see that now here in the area equation you have to mention the starting angle and the end angle of the required curve, because this is an integral that runs through the theta variable. So all these lower limits and upper limits are associated with theta, right? Also remember, r is a function of theta, so this whole integral will make sense, right? The same thing is applied to here as well. Okay, so now in the four-leaved rose, this is for the angle pi by 4, and now by symmetry you can say that this is for the angle negative pi by 4, right? So all we need to do is to compute this integral, and that means area is equal to AB half r squared d theta, and here starting like the two endpoints will be negative pi by 4 to pi by 4, right? And we have half here. R is represented as cos 2 theta, therefore r squared will be equal to cos 2 theta all things squared, right? And d theta. So this is just a simple integral where we can use integral techniques to find the answer, and that can be completed like this. You just square the terms, use double angle formula, and then directly evaluate the limit. So you will get pi over 8 as the answer. That means area of this portion will be equal to pi over 8 square units.